This is Mars, a cold and desolate planet, home to nothing but toxic dust storms and undrinkable water ice. It was once littered with failed launch attempts and exploration robots, some that have long since depleted their source of energy. 30 years later, it is now 2050. The water ice is now able to provide sustenance. The carcasses of dead science projects have been cleared and replaced with the visiting humans and swarms of construction robots performing many tasks. We look up in the Martian sky to see satellite constellations and become curious when we are greeted with huge fantastical structures. This is the same site, replicated in multiple locations within the solar system. At Earth, Mars, Mercury and Venus, we've teleported to a time 3 decades into the future in order to conduct analysis on the engineering progress and where we are heading next. Let us time travel together, onwards to the next step in the journey. This is why engineering. In 2050, we are likely to know if it's really possible to successfully reproduce in a low-gravity environment. Will low gravity significantly affect cells and internal organs, like it does for the growth of crystals and materials? If it so happens that we need as close to Earth levels of gravity as possible, it could actually force us, at least in the early stages, to create waypoints for non-work living and those in the throes of pregnancy. It would mean that we need a cheap way of getting off the surface of a celestial body and back again. Space elevators. This is the first technology likely to be the smartest choice that could operate with such frequency. If we look at the cases for each planet, we can list the materials that are theoretically strong enough to withstand the huge forces for each application. It will need to be presumably one continuous piece and support its own weight over vast distances. All of these materials have been produced, even in 2020. The issue holding us back right now is the difficulty of mass producing, especially the single crystal graphene, as it has only so far been created in lab conditions. The quality also has to be close to perfect. At those levels of stress, any defect can become a focal point for a rupture, snap, or tear. But with this solution, all it takes is a short amount of fuel to space hop to your local rotating station to normalise and reverse the effects low gravity has had on the body. This is by no means the only technology that can perform the function of easy access to space on a commutable basis. Once you can overcome the current limitations and take advantage of low gravity's ability to more easily lift and move large structures, many options become viable. But that is a topic to explore another time. If mass gravity is enough for reproduction, with or without introducing additional measures, then it becomes significantly quicker to spread the gift of life throughout the solar system. At this point, the majority of the population in space is likely to be of the non-breathing kind, even with solving that issue. Once the logistics of controlling a robot swarm is less of a complex task, and electronics are immune to high radiation effects, it becomes a no-brainer to act like the puppet master of a constant running, no resting, non-complaining robot workforce. With the emerging possibility of artificial intelligence, this workforce might adapt to sudden changes, proactively and reactively repairing vital infrastructure to make space safer for humankind. Even now, there is an explosion in the amount of sensors, monitoring every aspect to inform maintainers the electrical and mechanical status of a piece of equipment. Imagine in 30 years when this capability is standard practice. If you're not a robot, then obviously you need to eat. At this stage in our future time jump, grown meat, similar to the Impossible Burger, will already be a solved issue. This will have reached the industrial scale, massive structures specialising in the growth of meat and refrigeration. This is assuming we don't have tablets that provide calories and nutrients for a full meal. Though I think that would remove one of life's pleasures and won't be very well received. Rather, I think there will be a host of robots that can cook at the levels of a top chef. Couple this with thousands of delivery robots from a space warehouse, and we are in business. Each delivery spacecraft will have different energy sources dependent on its use. Because, since fuel is being made in space, and you don't need to fight the influence of a gravity well, packages could arrive as fast as you need them to. These delivery drones can run on solar energy, using ion drives, or are able to charge themselves by replacing hydrogen energy packs at waypoints in space. They can be airdropped onto a planet in an emergency, or slowly delivered in a large shipment to a space station or space elevator. On planets, water is extracted from ice, or converted from whatever chemical can be drawn from its atmosphere. While on a space station, elevator, and habitat, water is largely recycled from air, human perspiration, and showers. It's probably not at this point that the ice planet Europa has been utilised. On Earth, we are privileged to experience natural protection through the presence of a thick atmosphere. It protects us by providing enough friction for meteorites to burn up. Mars has a thinner atmosphere, and the Moon almost has none, so you can see where the problem lies. Initially, habitats are underground, gaining entry by old lava tubes or deep crevices created by ancient asteroid impacts. The Martian or lunar soil will coat the habitat, acting as a shield to protect occupants from radiation and provide a buffer for direct impacts. A satellite constellation equipped with an array of lasers can also be used to ablate or vaporize fast-moving materials in space. In addition, the ablating process can be used to deflect and change the trajectory of an asteroid destined for a dangerous collision. This is almost certain to be a smart idea to have in place. We all know what happened to those dinosaurs. Any habitat above ground could be surrounded by a Kevlar multi-layered mesh to dampen the energy of any missed fast-moving object. Though a much more elegant engineering solution can be implemented. If you introduced fixed radar overlaps and stationed in front and further out, as soon as an object crosses a path at a certain speed, motion detectors focus a laser on the object or fire a charge to cancel out the energy. Look at this demonstration of a laser cutting the warhead of an RPG clean off. You can see why I keep mentioning lasers. They are so versatile and fairly simple to manipulate. You might as well just call me Laser Boy at this point. The constellation will be used to help stations or satellites course correct and provide a boost of speed to delivery spacecraft should they require it. This is using a concept where laser light produces a pushing force focused on solar sails designed to reflect it back. This reflection doubles that pushing force. The Breakthrough Starshot project will be employing this theory in a practical sense to push ultralight nanocraft satellites at 20% the speed of light to Andromeda. How crazy it will be when around this time in the future, we receive close-up pictures from another galaxy 2.5 million light years away. You have to be proud of humanity and the sheer audacity to shatter the impossible. Entertainment has to be one of the first things we implement to prevent people from going mad. I can imagine new sports or reality TV shows being born from the inhabitants occupying space. What about you viewers? Can you think of any low gravity sports? I keep thinking of something similar to Final Fantasy IX Blitzball. A central mainnet will have broken the boundary of Earth, so that the wealth of knowledge stored on the internet can be accessed from distant planets. Relays and repeaters are used to boost the signal, and a quantum encryption layer will be added for security. As a side note, to cut down on the amount of data, it might be necessary to create a mirrored mainframe, hosting a replicated version that lags behind the mainnet. This would then only report the changes instead of streaming the entire dataset, though sophisticated solutions are required to manage conflicts and duplication. An environment normally needs to be comfortable for inhabitants to stick around. However, there is an exception to this. If an opportunity is temporary and lucrative, people will move, and there will be no lack of interest. There are many examples of diamond, gold, or other precious metals being found in a remote or difficult location. And within a matter of moments, whole bustling towns are erected. And when the work dries up, desertion and a hasty search for the next best thing leaves an eerie shell of human habitation, laid to waste and rot until it becomes dust. I can imagine this to happen regularly when a large enough asteroid is occupied, stripped of its valuable goods, and left to drift the endless depths of space, as a stark reminder that nothing lasts forever. Experts suggest that humanity won't exist in 8 million years. I think that our drive and passion to explore will prove them wrong. We literally have theories that can allow us to move planet orbits, stars, and whole solar systems. I'm sure we can prevent going the way of the dinosaurs. In summary, my vision based on the current efforts for 2050 ends with a positive outlook. Robotic-led construction will be the norm. Super strong materials will be mass-produced to allow for space elevators that will provide access to orbiting space stations. Laser constellations and other means will protect stations and habitats. A truly wide web will exist to provide internet to neighbouring planets, and the beginning of sports in space are starting to enter the minds of the masses. If you'd like to explore how humans are breathing in this environment, where and how these materials are being mined, and the energy sources in place to make this work, please see my previous video and project that forward to today for the full picture. Next time, on the next leg of the journey, we will time travel further into the future by an order of magnitude, where humans look very different, and our ideologies are a universe apart. Please like and subscribe if you enjoy the content, as this helps me get it out to more people. Thanks for the view, and have a beautiful rest of the week.